So we want to solve right triangle applications. From a point on the street, the angle of elevation of the top of the John Hancock building is 65.7 degrees. From a point on the street that's 100 feet closer to the building, the angle of elevation is 70.1 degrees. Find the height of the building. So let's go ahead and draw a picture. Here's the street, and then we'll make the building here. And if we go up to the top of the Hancock building, the angle of elevation, that's 65.7 degrees. Now if we move 100 feet closer, so we'll just put it right here, angle of elevation to the top is now 70.1 degrees, and this length right here is 100. And we want to find the height of the building, so that's h right here. And so let's call this distance from here to here x. So we've got two different right triangles, and we're going to need to use them both because we have both an x and an h. Looking at this closer one that has the angle of 70.1, connecting that with h and x, we have tangent of 70.1 degrees equals opposite over adjacent. Now looking at the larger triangle, we have tangent of 65.7 degrees equals opposite, which is h, over adjacent, which is 100 plus x. Now let's go ahead and solve both of these for h. So we're going to do that by multiplying this side by x, and we'll multiply this one by 100 plus x. Let me just put it in right here, 100 plus x. And now I can write these down. I'm going to write the first one down, which is x tangent 70.1. That equals h, but h equals this other expression, so I can plug that in for the h. So it's going to be 100 plus x times tangent of 65.7 degrees. Now we've got x in two different places here, so let's get rid of the parentheses by distributing, and then we'll round up the x terms. So I've got x tangent of 70.1 degrees equals, distributing that through, I have 100 tangent 65.7 degrees plus x times tangent of 65.7 degrees. So now what I need to do is get the x terms on the same side, so I'm going to subtract this term, and let's just write it down below. So we're going to have x tangent of 70.1 degrees minus x tangent of 65.7 degrees, so I subtracted this term, moved it over there, equals 100 tangent of 65.7 degrees. Now we have the x in both terms there, and so we can factor that x out. We're going to factor that out in front. We have x tangent of 70.1 degrees minus tangent of 65.7 degrees, and that equals 100 tangent of 65.7. Now trying to solve this for x, and so we can get x alone if we divide by all of this stuff. So let's go ahead and put that, I'll put it up here in red. X equals, we had this 100 tangent of 65.7 degrees divided by that stuff that was with the x, which is tangent of 70.1 degrees minus tangent of 65.7 degrees. Okay, now we can put that in the calculator, and what that will give us is what this length of this side x is, but then we can use right here, we know that h is x times 70.1, so whatever we get when we compute that, we can times that by tangent of 70.1. The main thing we want to do is leave the value we get for x in the calculator, don't round it yet, multiply it by the 70.1, and then we will be ready to round it. We'll give our answer to one decimal place. So when I put that in the calculator, I need to make sure that I get parentheses around the denominator so that it computes that correctly. So I make sure I'm in degrees, and then I put in 100 tangent of 65.7, and finish the parenthesis for tangent. Then I divide by, start a parenthesis for the bottom of the fraction. Tangent 70.1, finish that, minus tangent 65.7, finish that, and then a parenthesis to finish the bottom. So I get my x is 404.36, and it keeps going. I'm going to leave that value in the calculator, and I'm going to find h, which is the value in the calculator times tangent of 70.1. And with that I get 1117, and that's correct to one decimal place, and our units are feet.